Moving down in our list of instruments in Ableton Live suite is Operator. Operator is an FM synthesizer, a frequency modulation synthesizer. And to understand what that can do, we're going to dive in frequency modulation a bit. And frequency modulation is able to come up with pretty unique sounds that you cannot get out of subtractive synthesizers like analog is, for example. Of course, there are similarities like the oscillators, for example. Everything starts with oscillators after all. And in Operator, you choose your oscillator in the display in the middle where it says wave. And the oscillators themselves are here, A, B, C, and D. Right? Now for oscillator A, we have a sine wave. Very simple. I can also show you what a sine wave behaves like. I'm going to go to the audio effects and grab the spectrum plugin. There we have it. If I double click the display, it maximizes. So we have full view. Playing the C3 note on my keyboard now, which is about 260 Hertz. And it's a sine wave, so it's a pretty clean waveform. There's a little going on here, little movement here. But overall, it's pretty clean. Now let's try and get a bit of movement into the wave. We can do that with an LFO, a low frequency oscillator. And with the LFO, I'm going to try and bring some movement into the sine wave of oscillator A. Sounds a bit cryptic probably, but you'll know what I mean in a minute. I'm going to try and move the pitch of oscillator A. The frequency and pitch are the same, right? Let me reset these all amount rate and just show you what I mean. I'm just going to play the note. So I'm now modulating the pitch at a very slow rate. So that's the pitch of the oscillator. Let's turn up the rate a bit. If I do this enough, I can create a new waveform. And this is nice, but it's not really musical because the rate doesn't go high enough. So what we need is not a low frequency oscillator, but a much higher frequency oscillator. Well, what do you know? We have a couple extra oscillators right here, B, C, and D, and these can all modulate each other's frequency. So I could use oscillator B, just like we used the LFO, to modulate the pitch of oscillator A, the frequency of oscillator A. You still with me? Let me just show you how that works. As you can see, every of these 4 oscillators has its own color, right? Orange, blue, green, yellow. And that's the order in which they work on each other. We call that an algorithm. The current algorithm is found here. This is the way in which they influence each other. And what I mean is oscillator D modulates oscillator C, just like we did just now with the LFO. And the wave that we end up with then in C will modulate oscillator B, the frequency of oscillator B. And the result of that is modulating the pitch, the frequency of oscillator A. So it can get quite complex. The algorithm, the order is chosen in this display in the middle. So if I would choose this algorithm, nothing is modulating anything because everything is going out on its own. If I choose this one again, it just happens to be exactly this order. And there's a lot of variety in between. Like this one, C and D together will modulate B, which will modulate A. Am I still making sense? It's really not that difficult, is it? Not for you. But let's start out simple anyway. Let's take oscillator A, which is our sine wave, and we're going to try and modulate the frequency of that with oscillator B. Let's try and play you oscillator B. I need to pick the other algorithm for that, just to be able to play B. Now turn off oscillator A and play you B. Nothing happens because I need to turn up the level. And right now the level control is just a volume control, but that changes once I choose to modulate another oscillator. Then it'll change into an amount control, just like we had with the LFO. Let's turn on oscillator A again, and then I'll turn up the level control to modulate A using the sine wave of B. Okay, here we go. And what you're hearing now is a much faster modulation than the LFO did. And I can go slower if I want using the fixed value, because that will allow me to use a slower course or rate or frequency at which we can modulate the other oscillator. Okay, so I'll turn that on, and it's now on 100 Hertz times 1 multiplied by 1. We can take that down to 10 Hertz, and that's a little slower. But that's still not slow enough. Let me bring down multiply to 0.1 times 10 Hertz, which is 1 Hertz. So let's go check what that sounds like. Can you see it happening right there? So that is frequency modulation. Sorry about that. So a faster frequency results in a faster modulation, results in a different waveform, right? In this case, it's not a particularly good sound, but that's a different story. This might actually be usable as a starting point for a new sound in Operator. Let's go to the next tutorial and check out the rest of Operator.